Everybody, so I'm going to try to go through the process of extracting the information from the Nightscout app and being able to publish it on a M5Stack device. M5Stack is a really simple device that in this case is going to be used only to display the information that we want to collect from Nightscout. And in my case, it's coming from the Dexcom app. So I'm not going to go through how to install Nightscout. There's a bunch of videos, and I'll put the links in the description. But the idea is, once you have Nightscout up and running, your Dexcom or your CGM will be uploading the information in near real time to the monitor. And then Nightscout will be able to collect that information, store it on Heroku, and be able to display that as a website. What's nice is Nightscout has this amazing thing where it can not just display the information in graphical format and with alarms, etc. It'll also give you the access to programmatically connect to the website and get this data. So I'm going to walk that process through. So the first thing you'll notice is that you can see the data that comes in. And these are some of the key parts that I want to extract. I want to get how long ago was my last data point. I want to know, obviously, what the CGM value is, right? Or the blood glucose monitor value would be. And I want to see what the difference is with the prior value. So those are important things to see. When I go to the API, I would just do the same exact thing, but then do a /API v1 entries. And you'll notice in this case, I'm going to get a count of just one, which means I'm just getting one line of what the last value was. And in this case, you'll see the time in Greenwich Mean Time. You'll get a weird long number here, which is actually the number of seconds since 1970. You'll get the actual CGM blood glucose value. So this is the big number that everybody cares about. And then you'll get a trend. So in this case, it's not computable. So what I'm going to do is show you that you can actually do this. And this, by default, is measured every 5 minutes. So if I go and I say I want 100 counts, you'll see that it's actually going to show me 100 values here. So if I do 100 times 5 minutes, that's 500 minutes. I get a number of hours of data in one screen, right? And I can actually go and get more, but I really only care about the last two for the M5Stack device, because that's pretty much all I'm going to do is I'm going to compare these two lines. And this is important to understand because I'm going to have the old value and a new value. And I'll talk about that in a second. So if you haven't checked it out, go to Amazon and get the M5Stack. And then you'll see that there's a whole bunch of different ones that are available. I personally like the M5Stack. It's one of the cheaper ones, but obviously what I'm going to show you would work on any one of these versions. The M5Stack works on something called Flow, which is actually a Google product, or it's a free website if you want to think of it that way, where you can actually do programming and with Blockly. And Blockly is really cool because it enables you to do block level programming. So I don't know if you've done it with Lego or something else, but the idea is you can create a pretty simple program and then you can actually see the code in Python. So I am not a programmer, even though I work in IT and I do a bunch of scripting. So this is the kind of thing I could do, but the idea is anybody can do this, and part of why I wanted to do this in Blockly was so that people can understand what I'm doing and then potentially either decide to start programming themselves or add more stuff to this, and then we can share and collaborate and make diabetes monitoring fun, however that may seem. So anyways, here on the left, you can see the CGM, or I should say the M5Stack view of the world. And the idea is it's just a simple panel. The resolution of this is actually 320 in width and 240 in height. All right, so it's kind of a screen. So if you think of a modern 1080p screen, which is 1920 by 1080, here it's just 320 by 240. Okay, so that's important because any of our graphics are going to have to fit in that size. Then you'll see that there's a title. And in this case, I'm starting to already show some of the blocks that I created. So the title is important. The SGV label, so a label, which is something that we can change in the size of the text that's going to be used. So here you can see its position and XY values. And then also the font size that I'm going to use. So I use only standard fonts, and I tried to make it very explicit on what I'm doing. You'll also see that I did something called the diff SVG, which is the difference between the prior reading and this new reading. That's how you get the +10 or +1, -1, etc. And that's what I want to show. And I showed it in a smaller function on the screen with a bit smaller font. Here I strategically placed it next to where my blood glucose level would be. And then you can see I put a date label just to see how much time has gone by since the previous value, the trend label, and the direction label. So I just created a couple labels so I can see what was going on in the environment, right? So like any M5Stack app, you're going to start with a setup. And then in my case, and I learned the hard way, so thanks to Scott at Google for helping me with this part, is that you have to initialize all your variables. So a variable is just something that's going to change in programming. And the idea is I name my variables to try to make them as easy as possible to read. And the idea is you have to give them a value so that they're not empty the first time you run this application. So you'll notice I created a bunch of variables. So you can see here I created a counter variable, which is going to count how every time it goes through a loop. I'm going to see the old blood sugar value. I set it to 100. I don't even think I use this value anymore. I have the old date, and in this case I set it to 0, which is the prior time I checked for blood glucose. The screen brightness, which is super important because we realized that the M5 was actually pretty bright at night and it was actually distracting. So no use to making it more painful than it is. And then this diff SVG is the difference between the prior value and the new value. So that's the plus that we want to check. And then the time counter is how far in time have I gone by since the last time I checked. Okay. And I also set the speaker volume to 1. So there's a number of things that we're going to be able to do, like the button presses and things like that, where you just want to check that that's at a specific setting so that you can connect to that and not do something else, right? So since this is a single app, single purpose display, I'm going to set everything, and then the idea is it's only going to do that thing. Once that's done, you'll see that I start my main loop. And this is really important because this is the main loop of my program. And you'll see it's actually very short because I call functions when I want to do something specific. And so in this loop, I say do this until, and in this case, I have an empty block. So I could say, hey, until my program finishes, until the end of time. In this case, I never gave it a reason to finish because I always want this program to run. So the only time the program would actually end is if the device lost connectivity to Wi-Fi and it had to be rebooted, or if it actually ran out of battery and because it wasn't plugged in. So those are the only two conditions I can think of where this thing would stop. The idea here is the first thing I do is actually connect to Wi-Fi. So I check. So this is called a function. So to set variables, you'll see I can go to variables here and you'll see all the ones I have set. And then I'm going to call a function, which is going to say I'm going to call something and I'm going to do something. So the first function I call here is connect to Wi-Fi. And so here what I'm going to do is I'm going to switch the title bar from blue to red. And I'm going to say, hey, I'm connecting to the Wi-Fi. And then in this case, I put my Wi-Fi SSID and password. Once I've connected, it's going to say, hey, I'm connected to Wi-Fi. It's going to change it back to blue, and it's going to wait 2 seconds so you actually have time to read it, or else it goes so fast you wouldn't even have time to read it. So usually you'll see the first thing the device boots up, says it's going to try to connect to the Wi-Fi, connects to the Wi-Fi, and then it starts running. The next part is the major loop, right? If we want to think about it, is where I actually call Nightscout. So the idea is I'm not calling the web page, right? I'm not calling this page where I see all the data. I'm actually calling the API page, and I'm just calling one line. So this is important too, because I don't know enough about programming to start saying I want to know the difference between these two lines. I actually just call the line over and over every minute and say, hey, how am I going to get the data? So this is important. And for those of you who are having fun with M5Stack, you can actually learn how to do API calls. So in this case, I'm calling the Nightscout. And so what I tried to do was show whenever I do a function, and I put it on the right here. So here, since it's my main loop, I put it in the main body of the page. So here I'm going to go and I'm going to call Nightscout, and it's a GET request where it means I'm going to pull the information from a web page. So here, it's very important to put the URL that you have for your Nightscout app. So this should be exactly the same as what I have over here. And in this case, I would just want to get that one line, right? This is exactly what I'm calling once a minute to talk to Nightscout to see if there's anything new. So here you can see I'm going to say I'm going to get the, and it's important to see that I call the function, and when it stops calling the function, it's going to do a wait, and then it's going to keep going, or it's going to keep going down this flow, and then just start back at the top and just loop through this over and over. So here now I'm going to get that one line, and it's going to create a map. So this is important because the idea is I'm actually calling a JSON file, and I'm going to get that information and put it in another variable. So here, the variable that we're calling it is a list, and it's the list from web, right? Or I could call it list from Nightscout. But the idea is I'm getting a list, and I'm loading all the data that comes back from the list. So if I look at this data, it's going to be these 5 fields, right? And so I'm going to call those 5 fields, and then I'm going to name them. So in this case, I'm saying I'm going to create a list into JSON, and then I'm going to create a list from web, right? And I'm going to put it into this file. And then I'm going to set all of the variables to the reading that are set by the keys. So this is documented in the Nightscout application API, where the idea is the SGV, sugar glucose value, is set to SGV. And I've just been lazy and literally copied the value to the name of the variable. Then I get the date string of what's the human readable date, right? That's the big long date that's set here, where I can see the year, month, day, and hour, and 00Z is the time zone, right? That's Greenwich Mean Time. So there too, I haven't found a function in the M5Stack to actually translate that directly, right? There's some things in Python that can translate it directly, but I haven't found that in Blockly or M5Stack. So maybe V2 will have that. But the idea is today I'm just seeing the data in raw format. Then I get the date. So the date string was that long one. The date is actually the time in seconds since 1970. That's this big number. And believe it or not, it doesn't look like it changes, but it actually changes all the time. So it changes every 5 minutes. I don't think they go down to the millisecond if we wanted to, but I do that. And then finally, I look at the trend and the direction. So the trend only gives you a number from 1 to 4, and I think it translates to, is it going up or is it going down? I'm not using that in the display of the M5Stack, even though I have that information. So we'll see at another time what I do with that. So that's the get command that calls the Nightscout app and gets all the information that we need. All the rest of the program is all about how to display this app in the right format. So the first thing that I do is I actually flush the whole screen back to black. And that's important because when I draw the arrows and stuff, it's kind of fun on M5Stack. If you don't erase everything, it'll just pile on top of it. And so I need a way to make sure I have a blank screen. On a TV, that goes so fast that you actually never see it. But on this thing, you can actually see it. And what I do here is now I set a condition, right? So this is a condition. It's called logic in Blockly code. And the idea is I'm going to say if something happens, then do something, right? So if I go into my logic, I can see that if something happens, I can do something. And if it's not true, then I'll do something else. So in my case, it's pretty simple. If the blood sugar level is between 70 and 150, which is what I'm expecting it to be, then the color is going to be green. If it's outside of that range, then make the color red, right? So here you can see if sugar value is smaller than an integer, which is a number, 70, or if it's bigger than the number 150, then make it red. And if it's not, then it's green, which is exactly what it looks like when I go to Nightscout, right? So I try to mimic the design of Nightscout in this, this flow. Then I do a number of different functions. The first thing I'm going to do before even showing anything on the screen is I'm going to check to see when that value was created. And so then I get through a pretty extensive loop to see what are the information that I have. And so here you can see that I have the check new value function that's listed here. And what I do is I check the date minus the old date divided by 60,000, and I see if it's equal to 0. What that simply means is if the date that I have from a minute ago is equal to the date that I have right now, and they're equal to 0, that means I don't have any new data. So I don't really have anything to do because there's no information. So the only thing I'm going to do is, well, I'll show you in a second. So here I'm checking that if it's equal to 0, which would mean I don't have any new data. If the counter is equal to 0, that also means that it's the first time I run this program since it booted. So I need to account for that because remember, I'm only looking at one line of code or one line of data. And so if I only have one line of data, then I can't do a subtraction to see what the change was. So here I do a sub loop if you want to think about it. So if the counter is equal to 0, then set the time to first run. And remember, time is what actually show up in the title. If it's not the first run, then do this. This is important. The time is going to be the counter, and I'm going to add 1 minute because I run this once a minute, and I'm going to say no new update in the last minute. And I'm going to show that in this new variable. Else, what that means is I do have something new, and I'm going to say this is the difference in time in minutes, right? So it's the minutes since 1970 minus the minutes since 1970, right? So it's a ton of minutes. But it ends up being usually 5 minutes since the last reading. And then it's going to convert that time, do it minus each other, and times it times -1. Why is that important? Because I want to know the difference in the blood sugar value. So I'm going to take the new blood sugar value minus the old blood sugar value, and I'm going to times it times -1. And that's important because I want to get negative values if the number is going down. And then I'm going to set a counter here to 1 so that if I go through the loop again and there's still no new data, then I can say it's so many minutes since the last read, right? Remember that time? So anyways, now that I understand what data I've gotten, I can go and display things. So here I'm going to go down to the next part, which is display the data. So here, what's the data that I have? Well, I have the time of when that last value was collected. And so we showed you that you can have either the first run or however many minutes since the last collection of data, or however many minutes since it last got updated, right? Those are the 3 options. Then I'm going to show what the new blood sugar value is. And that's the most important thing. That's the big number that's going to be in green or red right in the middle of the screen. This big 136 in this case. So in this case, that's what I'm showing, right? At the end of the day, every time what I want to show is the big number that I got, which is the main part of this command. The next part is going to be is the number positive or negative? In order to get the plus, here you can see +4, I have to calculate that because it's not showing here in this line. So I have to see what it was before. So if I just do ×2 here, you'll see that I got 132 and then 136. So I did the math and I said, oh, it went up +4. I did the calculation to do that. And so here I have to show +4. Then number is negative. The negative is actually going to show up automatically, so I don't have to add anything to the front of the label. And then finally, what I'm going to do is I'm going to make sure that all my labels are white so that since I filled my screen with black, I want to make sure that whenever I publish something, they're white so that I can actually see it. And the last part of my call is showing the arrow. So this is the trend arrow that you see. So you can also see it here on Nightscout app. I have an arrow. In the calls that I do, you can see that I have an arrow as well. And so in the app, I actually went through and created arrows. So in Blockly, you can do XY coordinates to make lines. And so an arrow is just simply 3 lines. So I had fun recoding how to write lines. And you'll notice that I created a flat line, a 45 up line, a single up line, a double up line, and the double up lines show up in red. And then I do the same process going down, right? 45 down, single down, and then double down. So whenever the arrows are double up or double down, they will actually show up in red. And then the process starts pretty much all over, right? I'm now at the bottom of my loop, and so I go back to the top of the loop. I go back up to the top, way up here, and I wait 60 seconds. So that's the 1 minute that I'm going to wait between everything. And the idea here is I'm going to add a counter, and I'm going to add 1 to it so I know how many times I've gone through this loop. That was more for me for checking to see if I was iterating through all my loops, but the idea is I have that information and I can display it. Then I'm going to set the old sugar value to the sugar value so that I have whatever went through that loop the first time. Remember, I'm only getting 1 line of data each time. So I don't know if that's the right way to do it, but that's the way I do it, and it works great. So now I set whatever was there before to this value so that when I collect it again, I only get the latest value. Then I'm going to set the old time to time so that again, I'll be able to do a comparison, and then I'll old date to date again for the comparison. So that's when now I've waited 60 seconds. I've gone through the whole thing. I clear the screen and I start all over. So here it's going to start and check that Wi-Fi is connected. Normally it should stay connected. And if it's not, it's just going to run through the connect to Wi-Fi again. Then it's going to call Nightscout. And here you can go and see, and so on and so forth forever. Until the device disconnects or it gets rebooted. One of the things I did for fun was also create a condition for when buttons are pressed. I wanted to, one of the things that was clear is my son was getting annoyed at how bright the screen was. So I was like, oh, one of the simple things I could do is push a button to make the screen brighter or less bright. And so button A makes the brightness go down by -5, and button C makes the brightness go up by +5, and button B just resets it back to level 21. And the reason I did 21 was because if you do level 0, it actually blanks out the screen. So I don't want to blank it out. I want it to stay at a minimum at 1. So the idea is it'll go down by 5, but if ever it gets lower than 1, it just sets it back to 1. So what happens is if you push the button 50 times and you're now at -250, you would say I would want to be at now level 1. So it just stays very dim. Okay. I did not do that on the brightness side. I don't know if it gets much brighter than 100, but even if you press the button 50 times, I don't care. What it'll do is it'll just go as high as it can. And then if you press button B, you'll just go back to level 20 or level 21. And I do show screen brightness on the display. So you can see here, I show the screen brightness. So anyways, That's 25 minutes of how to write the Blockly app. I hope you enjoyed it, and then good luck with your diabetes. I know it's not easy, so hopefully this made it fun. Talk to you soon. Bye.